Hi everyone, my name is Urvin and today I'm making this video to demonstrate my task 4.3D in which I will be using timer interrupts with my Arduino Nano 33 IoT. So first of all, understand the difference between the internal as well as the external interrupts, and this task mainly focuses on the timer interrupt, but we will be understanding first of all what is an interrupt. It is because we are not telling the microcontroller to do two things at the same time, and interrupt is basically when microcontroller is doing something, uh, like it is blinking an LED, but suddenly we want it to do something else at that time. Like for example, we are working or doing any sort of task and we get a phone call. So first of all, we pick the phone call and then we answer it, and then we just resume what we are doing. So this is the concept for the interrupt, and here we will be addressing the Arduino to stop whatever it was doing and first do the instructions of the interrupt and then resume whatever it was doing. And this is how interrupt is worked. And we here is how we declare the function for the interrupt service routine. This is void ISR, and this is how it is declared. And there are some types of interrupts here. One is the internal and external, and second is the external. In the previous task, we have studied about the external interrupts, but what's the difference here is external interrupts are those interrupts that are caused outside of the microcontroller. For example, the LED button press. It's an external interrupt because it comes externally from out of the Arduino, and Arduino processes it outsidely and then follows the interrupt. However, talking about the internal interrupt triggered by an event generated inside the Arduino. It is a type of interrupt generated inside the microcontroller because, for example, the timer interrupt. If we say to fire a timer interrupt, which we will be doing in this task, because we want an LED to follow an interrupt after every 1 second of the timer, and that's how it is periodically fired. And this is one of the main feature of the internal interrupt, that it is periodic because it can be fired after a fixed interval of time. And second main feature of the internal interrupt which distinguishes it with the external is it doesn't require any pins because it is fired internally by the serial clock, and that's how it is working. And so let's move on to the code. And um, Okay, so here is the code part, and here I will be explaining what was the task requirements and what I have done, and also I have some additional implementations in this task as well. So first of all, let's study about the task. Let's talk about the task requirements, because here, our first requirement is to press the button to toggle LED 1 via interrupt. And it's an external interrupt because I have already explained, because it comes outside of the Arduino and hence it is an external interrupt. And second is the trigger the sensor 1 to LED to toggle LED 2. Here I have used two sensors which I'll be explaining. One is the BH1750 light sensor, and second is the HCSR04, which is the ultrasonic sensor. And he did. We will be focusing on this part because we want the LED3 to toggle automatically based on the timer interrupt after every fixed interval of 1000 milliseconds. And here we will be checking the serial monitor for the messages that are being logged. So let's move to the code part now. So here are some important libraries which I have used. Wire.h, which is and BH1750H is used for the light sensor because it involves the it involves the I2C communication. And this one is the RTC0, which we will be using for the timer interrupt. And so here you can see I have defined the button pins. This one is the ultrasonic and these are the LEDs. So I will be talking about the LEDs. One LED is toggled when and button is pressed. It's an external interrupt. And second LED is controlled by the light sensor. The third one is controlled by the ultrasonic. And fourth one is the timer interrupt, which will be blinking after every 1,000 milliseconds. And fifth one is the Morse code, which I will be explaining why I have used. It's an additional component that I have used. So we have set the states to low first of all to implement, and these are some modular programming functions that I have used inside the loop for my Morse code blinking. And so let's move here. Here you can see the external interrupt. The handle button is an external interrupt, and that's how if the button is pressed, we'll get a message as well as the LED will be toggled. And let's move on to the internal interrupt now. This one is the internal interrupt. In this code snippet, we are also adding an additional feature like reading these value for the light sensor as well as the ultrasonic sensor, because we require continuous readings for that. And that's how the internal interrupt can even help us to read the data from the light sensor as well as ultrasonic sensor after every 1 second, and that's how we don't need any implementation of those sensors to read continuously inside the void loop, and we can itself declare it in the internal interrupt, because when the internal interrupt will work, it will also get the readings from the sensors as well as it will be toggling that LED after every 1,000 milliseconds. So this was the whole snippet, and that's how we 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 are declaring the RTC.set alarm here, because we want the LED to blink after every 1,000 milliseconds. So these are some modular methods for Morse code blinking. Here's the void blink dot, and dot and dash are the components that are used to present the Morse code, and that's how I have made these respective functions. And this one is the for loop for following the Morse code. And here comes the setup function. Here I have set up first of all the sensor pins, LED pins, and here this one is the declaration for the attach interrupt for the button pin. It's an external interrupt, and that's how we declare it inside the setup. This is followed by attach interrupt, then digital pin to interrupt button pin. This we will mention the pin number, and then we'll mention the function that we have declared above, and then we'll talk, and then I have used the falling type, because there are three types for the external interrupt, which are falling is for the change when pin goes from high to low, because we want our button to press, it will go from high to low. So whenever there is any change, so that's why we have used the following type. However, there are the three types as well: low, change, and rising as well. So this one is the loop. Here I have used the modular programming as I have discussed earlier. Blink letter to blink my Morse code efficiently, and these are the delay. Delay is being declared inside the word space, and that's how my Morse code will work, and my internal interrupts will be working as well. This is the whole code. So let's move on to see how my task is working, how my project is working. Okay, so as you can see my complex setup here, and here you can see the first LED. The first LED is responsible for Morse code blinking, as it is blinking my name URVIN. And here is the interrupt which is fired, and that's it is fired after every 1 second. You can see it is blinking after every 1 second. So let's talk about the another LED, which is the yellow LED. It will blink when the distance will fall below the 20 centimeter, and the readings will be read by the ultrasonic sensor. So here you can see the distance is okay. So here I have held my hand over here, near the ultrasonic sensor to get the distance below 20 centimeter, and here the respective yellow LED will blink. And here you can see I have removed my hand, it has gone, and now I'll again show my hand over here. Now you can see the yellow LED again blinked. Now I have kept my hand near the ultrasonic again. Now you can see it is blinking over here again. So let's talk about the another LED. Another LED is for the light sensor, and you can also see the message has been logged when the distance is less than 20. Over here you can see this message is coming from the interrupt. And so let's talk about the another LED, which is this one, this over here. So this is my light sensor, and when I expose it to the light, the lux value will be increased, and hence the LED has its state as high. You can see this is also an interrupt. Okay, so let's make it all. So this one is the last LED. It will work when I will press this push button. So let's press this push button, and you can see it is working accordingly. So this was my whole task, and I have successfully explained my concepts regarding the external and internal interrupts. Thank you for watching.